My name is Heather Tausig. I lead the conservation work here at the New England Aquarium. Many of you, I think, know that we do a lot of conservation and research work here. I have a number of scientists here in the audience from projects working on things like coral reef conservation and shark conservation and research. And we do a number of programs, what we often refer to as sort of behind the scenes, but from our mission side of the house. So the New England Aquarium is really proud to be an institution that not only showcases a number of animals that you would see in the wild and also their habitats, and really educates about all of the things that go on in the oceans, but also does a lot of things on the ground, both here in New England and far across the world. So we're going to hear tonight from a scientist that's involved with or supported by our Marine Conservation Action Fund. I'm going to turn it over to my MCAF coordinator to tell you a little bit more about what that means. But I'm really here to let you know that this is part of a larger initiative that the aquarium leads. We have a lot of collaborators out in the field, and we work on a variety of things. I know there's people in the audience here who support our sustainable seafood work. We work with large companies that buy and sell seafood, and we work to educate the public on messages around how your fork makes a difference in the oceans and how we help protect the oceans. We also have a very large initiative working on a marine protected area in the Pacific called the Phoenix Islands Protected Area. Both of those projects are housed in the Conservation Department, but we have a lot of work that goes on both in conservation and research, both in our Conservation Department, our Research Department, and we work very closely with our Education Department, who communicates a lot of that work out to the general public. So I'm going to turn it over to Elizabeth Stevenson, who coordinates our Marine Conservation Action Fund, to let you know more about that.
Hey, it's a great pleasure to be here with you tonight to share this project, this Manta Ray conservation project that was supported by the Aquarium's Marine Conservation Action Fund. And I want to tell you a little bit about MCAF, as we call it, before we start here tonight. MCAF is a granting program of the New England Aquarium that supports time-sensitive, small-scale projects around the world. We have funded projects on every continent of the planet except for Antarctica, and of course there's still time yet for that. Since we were founded in 1999, we have funded 109 projects in 37 countries and given out $600,000 for various projects such as supporting a community marine protected area in Madagascar, monitoring whale sharks after the Gulf oil spill, protecting sharks in Costa Rica, and sending our own aquarium scientists to help rescue and rehabilitate penguins after an oil spill in South Africa, and a mass cold stranding of sea turtles off the coast of Florida. We have supported numerous sea turtle nesting beach protection programs in countries such as Costa Rica, Papua New Guinea, Indonesia, and India. MCAF is generously supported by several funders, including the Oak Foundation, the Curtis and Edith Munson Foundation, and of course the New England Aquarium. We also have generous individual donors, some of you who are here tonight, who have supported our program. And MCAF would not exist without our advisory committee. We have this great advisory committee of 14 scientists and marine professionals who evaluate all the proposals we receive. They give their own time to do this. In fact, we have several of our own aquarium scientists who are on the committee, and our shark specialist, John Mandelman, would you wave your hand, John, is on our committee, and which is great because we are receiving, thanks to John's input and just the way the world is going with sharks needing a lot of help these days, we're receiving more shark proposals and ray proposals. So we are very excited to have Daniel Fernando here tonight as he represents the important impact that MCAF grantees are having around the world. I'm also very grateful to the Lowell Institute for making these lectures free and open to the public, and for the Dive Club, the New England Aquarium Dive Club, for co-hosting this event with us tonight. So without further ado, let me introduce Daniel. Daniel Fernando grew up in Sri Lanka. He studied abroad and then returned to Sri Lanka to put his passion and knowledge of conservation biology to good use in his home country. As a scientist for the Manta Trust, he has documented the impact of the Manta Ray fishery in Sri Lanka and then expanded his work to India and Malaysia. His work has been featured in several documentaries, including Diminishing Ray of Hope and Man to Manta. And his research contributed directly to a very important victory for manta rays this past March at the Convention on the International Trade of Endangered Species, known as CITES, meeting in Bangkok, Thailand, where manta rays were afforded stronger protections as a result, in part to Daniel's research, and he'll speak more about that tonight. So, and I've also seen, spending time with Daniel, that he is, I can see how he very successfully navigates speaking with fishermen and fish markets, because he very coolly handled speaking with scientists today, as well as our campers from our camping program, 8th and 9th graders firing questions at him, and then handled very well under pressure the technology issues we have. So it is my great pleasure to turn over the podium to Daniel Fernando.
And I would like to first and foremost thank the New England Aquarium for having me here and giving me this opportunity to speak to you all. And of course, a very big thanks to the Marine Conservation and Action Fund that helped fund my research in the past 1 year in Sri Lanka. So, let me begin. Hopefully. Right, here we go. So, I'll just give you a very brief overview on what Manta and Mobula Rays are, and then talk a bit more about my research in Sri Lanka, drawing comparisons to a few of my other research locations, such as India. So I'm also doing a PhD at the moment with the Linnaeus University in Sweden. So all the data that I collect contributes towards my PhD as well. And I'm currently project leader in Sri Lanka, India, Malaysia, and Chagos for the Manta Trust. So the Sri Lanka Mobula Ray project, which is my primary project, was actually founded in April 2010. And this was afterwards incorporated into the Magna Trust, which was founded in January 2011, which was officially registered as a UK charity in the UK. As I mentioned, it's also my PhD in Sweden, and with a bit of collaboration with a local university in Sri Lanka. The Magna Trust is essentially a UK registered charity, and we focus on Manta and Mobula Ray research all around the world. We started off with just 3 projects 2 years ago, and we have over 16, probably even 17 projects running around the world. They range from location. Our primary projects are in the Maldives, Sri Lanka, Indonesia, but we have quite large projects in Mexico, South America, Hawaii, Fiji, Line Islands, Philippines, just to name a few. And yeah, we basically focus on a multidisciplinary approach, which takes into account, for example, research. We try and increase awareness, talks such as this, improve education, and we also work on a government level to improve legislation protecting both Manta and Mobula Rays around the world. So the Sri Lanka Mobula project has received several grants, again, thanks to the Marine Conservation and Action Fund. I also receive regular grants from the Save Our Seas Foundation, from a lot of support and funding from Shark Savers and Wild Aid. So just to give you all an idea, I'm sure most of you know where Sri Lanka is. Some of my other projects are in the south of India. I have a project running in Malaysia and Borneo, which is a project in collaboration with Scuba Zoo, which is an underwater filming company, and with Scuba Junkie, which is a very environmentally friendly dive center based in Semporna, which is one of the best diving locations in the world. Just recently, I have gotten permission to run a project in Chagos, which until last year was the world's largest marine protected area. And yeah, I'll basically be running an expedition early next year down into Chagos to try and learn more about the manta populations down there. So, what are Mobula Rays? As most of you will know, they are cartilaginous elasmobranchs. We know that there are over 1,000 species of cartilaginous fish, and approximately 500 of them are sharks and around 500 are rays. They are very old, over 400 million years old, and of course their skeleton is made of cartilage. Most of them have 5 to 7 gill slits, and in the case of both Manta and Mobula Rays, they have 5 gill slits. So of course, many of you will be familiar with sharks. They look very prehistoric, haven't changed too much. Here you can see a few images of probably the most prehistoric looking sharks. You get the basking shark on the top left, and you get the megamouth shark, which was actually a specimen which I recorded at a fish market in Sri Lanka. And this is probably the 58th specimen that has been recorded in the world. And then a few others, of course, the whale shark and the great white. So the Manta and Mobula Rays are essentially flattened sharks. That's the simple way of putting it. They have their gill slits on the bottom of the body instead of on the sides, and they have developed these pectoral wings to allow them to swim through the water column. They are quite recent, talking from an evolutionary point of view. They're only about 20 million years old. And at the moment, they're broken down into two genera. You get the Manta, which consists of two species. You get the Reef Manta Ray and the Oceanic Manta Ray. So the Reef Manta Ray is generally the smaller species and is constrained to several reefs around the world. For example, you'll get a population in the Maldives that stays just within the Maldives. Then you get the Oceanic Manta Ray, which we think can cross over much larger areas. For example, we believe that the Oceanic Manta Rays will be traveling across the Indian Ocean. We're not sure whether they cross between different ocean basins, but we are trying to study more about that as well. And yeah, within the Mobula family, there are currently 9 species. However, there is a chance that this will change in the near future because some of these species haven't been properly described and we're still lacking genetic information for them. So basically, with both Manta and Mobula Rays, we do not have much information. We don't know how long they live. We don't know where they give birth. So we're just trying to learn all this information. And of course, due to the threats that they're being faced with, which I shall talk in a bit, we need to do this quite fast. So first and foremost, how does one tell the difference between a Manta and a Mobula Ray? The easiest feature that we can look at is the position of the mouth and the jaws. So if the jaws are terminally aligned, then it is a Manta Ray. And if they're undercut at the bottom of the body, then it's a Mobula Ray. There are a few other variations, of course. For example, Mobula Rays are generally a lot smaller than Manta Rays, and there are variations in the spot patterns as well. But this is probably the easiest way to identify the differences. Just to give you a few facts about Manta Rays, they have a global distribution along the tropics and the subtropics of the world, and Oceanic Manta Rays can get considerably large. Here we see a Manta Ray. This is around 6 meters. And the Oceanic Manta Rays, which I see at the fish markets in Sri Lanka, range from about 2 meters to about 5.5 meters. The Reef Manta Rays, which we see very regularly in the Maldives, max out at about 3.5 meters. So they're considerably smaller, however, still quite large. So how do mantas feed? Well, they basically have to keep swimming through the water column constantly to get the plankton. And of course, since they grow so large, they need to keep doing this on a very regular basis. They cannot stop at all. And they have these very large mouths and these gill plates, which allow them to filter the tiny plankton from the water column. And Manta Rays feed exclusively on plankton. A few of the Mobula species, which are smaller, sometimes feed on small fish, but again, generally on plankton. And their primary source of nutrition are the mysid shrimp, which is similar to blue whales, for example. And in certain locations in the world where this plankton accumulates in large quantities, you can view mass feeding events. And one of these locations is in the Maldives, where we have our primary project running. And here you can see up to about 250 Manta Rays in an area the size of a small football ground, if you're lucky. Manta reproduction. We know that Manta Rays give birth very rarely. For example, the Oceanic Manta Rays and the Reef Manta Rays probably give birth only once in 5 years. They give birth to one single pup. There have been no documentation of twins or anything more than one. Their pregnancy lasts from 12 to 14 months. And the baby, when it's born, is usually at least 1.5 meters wide. And of course, this is quite big for a baby, so the only way it can be inside its mother is if its wings are furled up. So I have a few images from, again, sadly, of the fish markets, where we can see an unborn manta pup on the left-hand side and an unborn Mobula pup on the right-hand side. So as you can see, their wings are curled up, and when they give birth, they unfurl their wings, start swimming, and they're completely independent from their mother. So in the wild, just because of the size of these manta rays, they have very few natural predators. Occasionally a tiger shark may attack it, or a killer whale, but they're quite resilient to this. The manta rays are very fast, and they're quite large, so very few natural predators actually exist. Sadly, one of the largest threats to both manta and Mobula rays are the anthropogenic threats. One of the major causes for manta deaths is bycatch in gill net fisheries. There are occasional records of manta or Mobula rays getting caught in shark nets placed around beaches, in the tuna purse seine fishery, and occasionally in mooring buoys. The reason they get caught in objects like mooring buoys is because mantas have to keep swimming forward. They cannot just stop and go backwards. So when they get caught to a single line, they keep swimming and then quite often do loops and just get entangled. So to focus a bit more on what I am actually studying, this is the Indo-West Pacific region. And here we have two of the, essentially both manta species are present in this area. We get the Manta biroscris, which is the Oceanic Manta Ray, and the Reef Manta Ray. At the markets, I'm seeing mostly the Oceanic Manta Ray. Sadly, both of these species are listed as vulnerable on the IUCN Red List and do not have much global protection. They're both listed under CMS, which is the Convention on Migratory Species. However, most countries do not actually implement these regulations, so therefore they're not that well protected. Last March, we were quite fortunate, and we managed to get mantas listed under Appendix 2 of CITES. And CITES is the Convention on the International Trade of Endangered Species. So from next year, September onwards, the trade of any manta parts will be managed and regulated. So we hope that this will decrease the fishing of these species. And this meeting, which took place, was thanks to a global coordinated effort by several individuals around the world, and one of whom is Mary O'Malley, who is in the audience here with us, and without her dedication, this would probably never have occurred. So I would just like to thank you for that. The other species that we have in the Indo-West Pacific region are the Mobula species. We have 5 species, and 3 of them are listed as near threatened, and 2 of them data deficient. But given their life cycles, we are quite sure that they are also highly threatened. And these are all very vulnerable to the fisheries. The target fishery for these species is very limited. Very few countries specifically target them. I will go into this in more detail. We get countries such as Africa, Mozambique, Mexico, which had a large manta fishery, which essentially collapsed in the early 1990s and mid-1990s and hasn't really recovered since then. And Indonesia, which currently persists. In Sri Lanka, where I'm studying, they are landed as non-discarded bycatch. But I like to term this more as targeted bycatch. And the reason is that even though the fishermen are not specifically going out to catch manta and Mobula rays, they're very happy when they catch them because they're worth quite a lot of money. And instead of releasing them, because sometimes when they bring them onto the boat, they're still alive, but they refuse to release them because of their value, and they will somehow kill them and bring them back to shore. And killing them often means cutting them in half when they're still alive. So this image, what you can see here, is quite common at a Sri Lankan fish market. These are all Mobula japonica. I'll just show you. Here's another image. This is a Manta biroscris, an Oceanic Manta Ray. This is a juvenile. It's probably about 2 meters, 2.5 meters. Here we have a baby Mobula japonica, which was probably aborted during the stress the mother underwent when she was caught in the nets, because it's very small. Here again, we have a very common scene at the markets. This particular market, I average about 25 to 30 Mobula rays a day, and about 1 manta every 2 days. This was an unusual day where we had about 140 to 150 Mobula rays. So in India and Malaysia, it's a very similar situation, but generally on a smaller scale. So again, you'll see some similar images. This one is from India, again, Mobula japonica. You can see with some tuna. So here again, on certain days, there are larger numbers that are being landed. So what's happening with all these Manta and Mobula Rays? We know that their meat is not worth a lot of money. It's consumed by very few local communities when it's fresh. For example, in Sri Lanka, there's just one community that consumes it, and they would probably eat maybe 1 or 2 Mobula a day, which is not a very large number. And the meat of Manta Rays is not consumed fresh at all because it's considered to be very sandy or grainy. So most of this meat is dried and sold as dried fish. And dried fish fetches only $1 to maximum $3 per kilo, which is not a lot. However, the main driving force behind this fishery is the gill plate trade. So the gill plates are basically the cartilaginous structures which are present inside the mantas. It helps protect the gills and also enables the mantas to strain the plankton from the water column. So this is essentially how they feed, using these gill plates. So these gill plates are basically removed from the head of Manta and Mobula Rays. The excess tissue and flesh is removed, and then it's dried in the sun for a day or two until you end up with this final product, which is a dried gill plate. I'll just show you a very short clip now of the process by which they do this. This was taken from an Al Jazeera documentary called The Diminishing Ray of Hope.
In the fish market in Colombo, we find a warehouse dealing with rays caught fresh off the boat. And today, we bought about 120 to 130 rays. Bring them here, where the workers clean them. Some cut up the heads, others wash and salt them, and the rest remove the gills. That's how we process them. We don't salt the gills though. We dry them. With the hot sun, they will dry within a day and a half. Mobula gills are $80 to $120 a kilo, and manta gills are $160 a kilo. The buyers come from China and India. The Chinese buyers take whatever we have and pay up front. It's better for us. They come once every 1 or 2 months and usually call in advance. They always return for more. They buy from dealers all over Sri Lanka.
Anytime there's an order, an exporter in Sri Lanka can easily round up 200 kilograms of dry gills within a week. That's the rough equivalent of 500 dead Mobula Rays or 100 mantas.
So as you can see, the quantities that are being caught, dried and processed is quite large. So what's happening with all of these? Simple answer is that they're being exported to China, where it's being used in traditional Chinese medicine. Now, even though it's classified as traditional Chinese medicine, there is absolutely no evidence that it's present in any of the old texts. So it seems to be more of a folk medicine that has taken off in the last few years as the Chinese economy has rapidly expanded. And this demand has, of course, created a massive fishery in countries such as Sri Lanka and India for these Manta and Mobula Rays. And just in case you're wondering what exactly the Chinese believe this cures, I will show you again another short video clip, which is an interview with one of the shopkeepers in China selling these gill plates.
Liang Yongchao runs a dried seafood shop. It sells anything from under the sea, including what we're looking for. Manta gill plates cost $420 a kilogram here, 2.5 times more than in Sri Lanka, and similar to the price of mid-ranged shark fins. Liang Yongchao swears by the medicinal benefit.
嗱呢啲彭魚菜咧，我哋自細咧細路哥出馬，咁啊當佢出完馬之後咧，就一定要買嚟食㗎。
用什麼方式來準備這種所謂的藥材？
咁咧呢啲咧可以清熱散毒，可以用佢煲粥煲水嚟飲，亦都可以咧用芫茜水煲佢，愛嚟抹身沖嘅。
怎麼知道分量用多少？
呢啲係民間嘅驗方嘅啫，差唔多嗱呢度咧咁一塊，我分2次啊3次咁咯，細路哥小朋友數十年來都係咁噶啦。咁啊大人咧，你有暗瘡啊之類咧，都可以清熱毒嘅。
這個有中醫的根據嗎？
中醫啦，好多樣嘢都係 早上傳落嚟嘅驗方，你話有咩根據啦？咁我真係唔曉講喎。
So as you can see, it's supposed to cure a variety of illnesses. We have also heard that it cures asthma, chickenpox, and cancer. Of course, there's absolutely no scientific proof that manta or Mobula gill plates can cure any disease. So the big question is, of course, is this sustainable? We know that Mobula rays have very slow growth rates. The Reef Manta Rays can live for at least 40 to 50 years, if not longer. Oceanic Manta Rays can live at least 80 to 80 years, probably even more than 100 years. And it's probably very similar for the smaller species, the Mobula Rays. They have very few natural predators, and they have a very low fecundity and late maturity, which means that they give birth only once in 5 years to one single pup. So of course, all this means that their life cycle is incredibly slow, and any directed large-scale commercial fisheries will have a severe impact on their global populations. So my research basically focuses on the expansion of the knowledge on both biological and ecological aspects of mobilids, and of course to try and evaluate and quantify the fishery that's taking place to try and determine whether it's sustainable and what measures need to be taken. So my primary focus site, as I mentioned, is in Sri Lanka and South India. Here you can see a shaded area. This is essentially the distance that the boats in South India travel when they go fishing for these manta and Mobula rays. As you can see, it's not a very large distance, and that's because of the size of boats that they have and due to certain governmental restrictions on fishing in India. In Sri Lanka, these are the three markets that I regularly survey, and these boats can go out much further. They're multi-gay trawlers and have the capability to stay out at sea up to 3 months. And I have recorded boats going as far as Somalia, Indonesia, Australia, and Chagos. So they go throughout the entire Indian Ocean, which of course creates another problem because you're not talking of just a local fishery within Sri Lankan waters. It's throughout the entire Indian Ocean. So here we can see these are the boats which are used by the Indian fishermen. They're relatively small, very basic. They have a sail which they put out when they're out at sea, but they also have a small inboard engine. They're restricted to about 50, maximum 60 nautical miles out to sea. They don't spend longer than 12 hours out at sea in general. They use very small, basic gill nets, which target pretty much all the reef species that are out there, and also the occasional manta and Mobula rays. They land generally much smaller species. Here you can see some of the reef fish and a reef shark that they have landed. And a lot of red snapper and grouper, which is generally exported to both Europe and the US. In Sri Lanka, as I mentioned, the boats are considerably larger, and they use much larger gill nets. And they target more pelagic species, such as the yellowfin tuna. We have various billfish. This is swordfish, marlin, and sailfish. And of course, pelagic sharks. Here we have greater hammerheads. Now I'll just again show you another very short video which just shows some of the Sri Lankan fishing.
In Sri Lanka, fishing boats travel hundreds, sometimes thousands of kilometers as far west as Somalia, even crossing the Indian Ocean to Indonesia. They cast nets for tuna, sailfish, and swordfish, often landing rays as bycatch. Until recent years, fishermen like Nyana Dasa avoided them. They entangle and damage nets, and their meat is cheap.
We used to release those that were still alive. We even cut our nets to free them. Now we don't release them even if they completely mess up the nets. The market has really increased for their gills in the last few years. They are profitable because they are dried and exported. 1 kilo of manta gills fetches $140.
The Sri Lankan government encourages fishermen to use longline fishing. It reduces bycatch, though not completely. Nyana Dasa's boat has a long line with over 300 hooks, able to spread out over several kilometers in the sea. but he prefers nets.
You can pull in 50 to 60 sharks with this line, or up to 100. But sometimes you get nothing, not even enough to pay for fuel. If we are lucky, the net catches 300 or 400 kilos in a couple of days, and we can go home. The net will always catch something, be it ray, shark or tuna. Always. When we lay out 300-400 hooks and get nothing, it frustrates us to death.
Yeah, so as you can see, most of the fishermen prefer gill nets to other methods, but sadly that's probably one of the most unsustainable fishing techniques that currently exist, along with bottom trawling. So my work at the fish markets, both in Sri Lanka, India and Malaysia, focus on data collection, the identification of species, their gender, maturity, and of course the dimensions. I also collect a lot of tissue samples, which are then exported and sent to other countries for population genetic studies, stable isotope analysis, and heavy metal analysis. And all of this will give us an idea of the populations of Manta and Mobula Rays, whether they are which areas they migrate to, and also what they feed on. A typical day for me at the market starts at around 3 o'clock in the morning, and I have to drive an hour to the market because the fish market already opens at around 3:30. So once I'm there at the market by around 4, that's just when they start unloading the larger species, such as the sharks and the rays. And then I basically record every single Manta or Mobula Ray that's landed, try and collect as many DNA samples as possible, collect measurements, take a lot of pictures, also gather some data about the sharks that are being landed, and just as much information as possible. And over the last 3 years, I have done over 500 surveys at the markets. I've collected data from over 4,500 individuals, detailed measurements from over 700 individuals, and collected over 500 tissue samples, which is probably one of the largest tissue databases for Manta and Mobula Rays. Some of the preliminary data that I have collected shows that of the total mantas that I have recorded at the markets, approximately 86% were juveniles or subadults. This is again another figure that's quite frightening to us, because it indicates that there is a possible nursery ground somewhere close to Sri Lanka or India. Of the total Mobula species, we see something very similar. In India, approximately 84% were juveniles and immature, and in Sri Lanka, at least 50% were juveniles and immature. Another very interesting factor was the frequency that mobulas were being landed at one of the markets in India, and this showed a very seasonal variation. For example, from May until around September or October, there were much larger numbers of Mobula Rays being landed. And this possibly indicates that there is some seasonality to these species and that they are migrating in certain times of the year. But of course, these fisheries are then specifically targeting them. So what does all this mean? We know that this data shows that there is a possible seasonal aggregation taking place, possibly in the north of Sri Lanka towards India. There is a possible nursery ground within the Indian Ocean, which would be one of the first nursery grounds recorded for these species anywhere in the world. And basically, all this data which I'm collecting can help evaluate the sustainability of this particular fishery. So out of all the data that I have collected, when you just do a general evaluation, just from 2 of the landing sites in India, I'm recording around 15 Manta Rays and 2,000 Mobula Rays per year. This is just from 2 very small fish landing sites in India located within 30 kilometers of each other. So it's not a very large distance. And when you consider the Indian coastline, it's probably a much larger figure for the whole of India. In Sri Lanka, the situation is much worse. We have around 300 Manta Ray and around 19,000 Mobula Rays being killed every year just from 3 landing sites. And again, there are probably about 10 to 15 major landing sites in Sri Lanka. So this figure will be much higher once we evaluate all of them. So why should we care? Well, both Manta and Mobula Rays serve as key indicator species. This means that we can use them to assess the quality of a marine ecosystem. So if the Manta and Mobula Rays are being fished out or are declining, We know that the other fish stocks are not doing too well because fishermen are changing their fishing methods, going for other species which were previously not very viable. The alternatives. We know that a manta ray, when it's alive, is worth $1 million due to ecotourism. And in comparison, it's worth only around $500 once it's dead. So one of the main things that we're trying to increase is, of course, ecotourism. Thanks to a paper that was recently written again by Mary, we see that the ecotourism is worth at least $140 million annually around the world. The Maldives, for example, makes at least $8.1 million. So this is one of the key things that we're trying to convince governments, to change. For example, Indonesia is leaning towards banning both the Manta and Mobula Ray fishery in favor of ecotourism, and we hope that they will go through with this in the next few months. Another great alternative will be sustainable fisheries. You'll wonder why I put a picture of such horrible tuna up. And the reason for this is that in Sri Lanka, a lot of the tuna that's being landed is of a very poor quality. And the reason for this is due to demand from Western countries such as the US, Europe, Australia, Japan for very cheap tuna. And in order for countries to supply this very cheap tuna, they have to catch them in large numbers. And quite often they resort to unsustainable fishing techniques, which of course land a lot of bycatch, such as Mobula Rays, quite often even dolphins, turtles, and so on. Another issue with the fisheries in Sri Lanka is that their boats are not very technologically advanced. They lack simple things such as refrigeration on the boats. For example, when they go out to sea, they just fill up their boats with ice, head out, and of course, you're in the tropics. The ice is not going to last very long. 1 month out at sea, the ice is gone. The fish starts rotting, goes bad, and when they come back to shore, they don't care about the fish too much. They just chuck it off the boat onto the ground. You get dogs running around, people spitting, people walking barefoot. Quality is very low, and then they wonder why they don't get high prices for the tuna. An alternative here, as you can see in this video, is like in the Maldives, where they have switched to a pole and line tuna fishing technique. And this is a very sustainable method. It's essentially where they spray water into the ocean and throw a little bit of bait, and the tuna thinks that there's a lot of feeding going on. So all the tuna comes to the surface, and just with a hook and a line, you can catch a large number of tuna. And this technique is very sustainable, and it targets one specific species, in this case tuna. So this is what we need to tell countries to switch to. As you can see, the quality is much higher than that in Sri Lanka. So if you can convince Sri Lankan fishing boats and all that to switch to this more sustainable technique, then we can also reduce bycatch of Manta and Mobula Rays. And the only way this can happen is if people in more developed countries are willing to pay the extra amount of money required to fish in a more sustainable method. Another very important thing is, of course, the declaration of marine protected areas. One good example of this is the Chagos Marine Protected Area in the Indian Ocean. And these areas not only protect manta rays, but many other species. Because after all, it's not just about manta rays. There are many species that are at risk. Our oceans are severely overfished, and most of our fish stocks are heavily depleted. And one of the great things about manta rays is that they're so iconic. People just like them when they see them. It's very easy to feel passionate about a manta ray, and therefore we can use these species as an excuse to help protect other species as well. We can declare marine protected areas around manta rays, around sharks, and then all other species become protected as well. These are some of the other species that are at great threat. So we cannot forget this. I mean, it's of course important to protect species such as Manta and Mobula Rays, which will most likely go extinct in the next decade or two if we don't do anything about it right now. However, there are other species that require our attention as well. And using key iconic species, we can help protect all of them. Some of my work will, of course, include the long-term monitoring of the markets and the trade. Again, try and improve the biological data that we have for these species to learn more about them, see how we can protect them. and see if there would be any way to have a sustainable fishery. And of course, you develop management strategies both on an international and a national level. So how can you help? Well, you can spread the word, raise awareness, tell people about this. A lot of people don't know what manta rays are, first of all. Of course, a lot of people who are divers know about manta rays, but have absolutely no idea that a fishery for this species exists, and not on such a large scale. So tell people about this, make them aware, use, of course, things like social media and all, spread the message, and basically get everybody to understand why we need to protect these species. And of course, another very simple thing is just beware of what you actually consume. Because after all, decisions that you make in countries such as this will affect fishing even in countries as far as Sri Lanka. Because if you make the decision to pay the extra money for a pole and line called tuna, it will help change the fishing techniques. So with that, I would like to end. I would just like to thank Al Jazeera for allowing me to show this, show the short video clips. And of course, a variety of people such as, again, the Marine Conservation and Action Fund and the New England Aquarium, and quite a few others who have helped me fund my project and also supported me in several ways. Thank you very much.
Feel free to ask questions of Daniel, but also of, if you'd like to know more about any other projects with the Marine Conservation Action Fund, or actually anything that goes on here at the aquarium. So, in the back.
Yes, has the truth and labeling laws, had any impact, on fisheries and on conservation efforts?
Okay, so the question, that's not on, testing. So the question is about truth and labeling laws and have they had any impact on fishing companies and fishing efforts? Do you want to field that from the point of view?
More on sustainable fisheries,
Yeah.
I believe.
So I have a couple thoughts on that. We work with really large purchasers of seafood. So the New England Aquarium actually has a corporate partnership program working with the parent company of Stop and Shop here in New England, the parent company of Red Lobster Restaurants in Gorton's, based in Gloucester. A number of these companies that are really paying attention to corporate social responsibility in terms of the seafood that they purchase are also paying a lot of attention to this word traceability, and have been for quite a while. And one of the challenges in the seafood industry is that there are a lot of links in the supply chain and a lot of opportunities for things to be mislabeled, names to be changed. There's a lot of things that go on even with chefs and restaurants where something sounds good to be called this, and people want to buy it. They don't want to buy slime head. They actually want to buy orange roughy, right? So names get changed, and there's a lot of work going on not only in the conservation community to address this, but certainly in regulatory environments. There's actually a law in the federal government right now called the SAFE Act that's trying to address fraud and changing of names. So, I think there's been a lot of progress, and I think that there's a number of companies that have some technological solutions to try and trace back the fish and know exactly what they're serving. They're very interested in making sure, most companies, I guess I would say, are really interested in making sure that what they sell you is really what it is. They certainly don't like to be caught selling, calling something grouper and selling tilapia and be caught out in that way. So there's a lot of work, but I think there's also still a lot of work to be done. And there's a lot of efforts going on to address that. I don't know, I can't speak specifically in relation to manta rays for that, but hopefully that answers your question. Yeah, right here.
It's obvious, but I presume there's no hope for reducing the demand in China.
Well, I think things are changing. Education in China is improving significantly. So I believe there is hope. I wouldn't put that completely out of the picture. As you can see with the shark fin trade, that has changed quite a lot due to a lot of propaganda in China. A lot of celebrities have openly declared that they're not going to consume shark fin soup any longer. And of course, the young population quite often follows these celebrities. So that is changing, and we hope to do the same with mobilate gill plates. So I believe there is a hope that we can change things in China as well as other countries. Yeah.
Yeah.
all fishery stocks are assessed by dead number of fish and they're killed. Is there any technologies that can actually measure live fish and live fish?
Can you repeat the question?
Can you repeat the question?
Yeah, so the question was a statement about most fish stocks are assessed through dead fish or through landings and catch data. And is there any way to assess populations through technology advances, through being able to study, for instance, fish in the water?
Like assessing
Well-
populations, like
Yep.
what the actual population
Right.
Yeah, sure. With Manta Rays, we have a very good advantage, and the reason for this is the spot patterns that you get on the underside of Manta Rays. So, for example, here on this Manta Ray, hope you can see this. There are basically very unique spot patterns, and each Manta Ray has a different spot pattern. So, simply by swimming with these Manta Rays and taking a picture, we can identify each individual Manta Ray. In the Maldives, where we have our largest database, we have recorded over 3,000 individual Reef Manta Rays. And this project is being carried out in several countries. So we are trying to learn more about the populations just by looking at the living populations. Another piece of technology that we use is, of course, satellite tags. And these are essentially small transmitters which we attach onto a Manta Ray. Again, with Manta Rays, they have a very thick skin, so you can put something about an inch inside their body and they don't feel it at all. So that's great. We basically go and anchor this little transmitter inside them, and every time they come to the surface, it sends off a signal to a satellite and lets us know where exactly the Manta Ray is. As the Manta Ray is diving, it collects a lot of information about the speed the Manta Ray is going, how deep it's going, the temperature of the water, the light intensity, and all this gives us information about the Manta Ray's behavior, where it's swimming, and so on. One of the disadvantages of this technology is the cost. Each tag costs us about $5,000 US. Sometimes the tag can malfunction. These tags are built in a way that after 5 or 6 months they pop off and float to the surface and transmit a lot of their data. Sometimes that can malfunction, or it pops off after 2 or 3 days, which means that we lose a large amount of money. So it's not the best solution, but we are going for it. And of course, we do require a lot of funding for this. Yep. Sorry.
Have there been any efforts to work with some of the liveaboard boats, like in the Maldives, with any of the accounts or any data collection? Just even with photographs. I know there are efforts right now to collect data on whale sharks with the spot patterns, and efforts of involving like citizen scientists to do that. I'm wondering if there's any efforts to try to work out something like that in the Maldives as well.
So the question was basically if we are working with liveaboats in countries such as Maldives to help improve our data collection and using normal people. Sorry, no. Maybe consider it, sorry. But basically, yes, the answer is yes. We are working with a good number of liveaboats in the Maldives. They are collecting a lot of data for us. And we have, on our webpage, we actually have this form which you can fill out. So if you ever go swimming with a manta or Mobula Ray anywhere in the world, you can just put this picture on our webpage, upload it with information of where you saw it, when you saw it, how it was behaving. And all this information goes into a global database which we are recording. That database is open to the public. So if you submit an image and we find a match, we will actually email you and tell you all the information that we have on that manta ray. And in the Maldives, this is very successful because we have over 3,000 mantas on our database. So there's a good chance we'll tell you which manta ray it is. They have all been individually named. So if you're very lucky, you might find a new individual, in which case you're allowed to name it as well. So please do swim and find some mantas for us and send us pictures. Yeah.
Setting up MPAs is very important, but I know that I had heard specifically with Chagos that because it was so large and there wasn't a lot of funds to be able to actually patrol it to make sure that there wasn't any, sort of illegal fishing going on. And you having worked there, what are sort of your takeaway from that, whether or not they're actually successful in that way?
Yeah, so the question was with regard to Chagos, how successful it was, because there is very limited funds and only one patrol vessel around Chagos. So how successful is it actually in preventing illegal fishermen from coming in? The answer is that it's not very easy. It's not the best solution we have. Chagos is underfunded. There is only one patrol vessel for one of the world's largest marine protected areas. However, a large number of fishing vessels that used to go into Chagos do not go in anymore because they can be easily detected. I do know that a good number of Sri Lankan fishing boats are going into Chagos illegally because they're quite small and they can easily get in. But again, I mean, it's not an ideal situation, but it's better than nothing. At the moment, only around 1% or less than 1% of the world's oceans are actually protected. And this includes paper parks, which are essentially parks just on paper. There's no enforcement at all. And a majority of these parks are in the tropics in developing countries such as Sri Lanka. I know in Sri Lanka, for instance, we have at least about 4 or 5 marine protected areas, and 0 out of them are protected. So you can literally go in a marine protected area and dynamite fish, and nothing is going to happen. So we do, of course, have to work a lot on this, but it is the first step in the right direction. A lot of developed nations are working with this. Australia has declared some of the world's largest marine protected areas. We are moving forward. Several private organizations are helping to run these marine protected areas. And I think this is one of the best ways we can move forward. It's better than no protection at all, and it's a step in the correct direction.
Yeah, I'd like to add just a few thoughts on that, because we work in collaboration with Conservation International in this large marine protected area in the Phoenix Islands in the Pacific. And we think about this issue of enforcement a lot, and there's a number of things to think about. Well, I mean, the first thing that I would mention is that Chagos and the Phoenix Islands protected area and a few other large marine protected areas actually created an organization, sort of an umbrella called the Big Ocean Network. And it was to bring managers of those marine protected areas together to grapple with things that you deal with when you're dealing with a large marine protected area that's very far away, remote, and et cetera. So enforcement is one of those sort of big push button areas. But I guess one of the things that there's a couple things that we've been exploring. So some are partnerships with other countries, and the Phoenix Islands is actually owned by a least developed country, Kiribati. Looks like Kiribati on paper for those that you have seen it. But there's a lot of agreements with Australia, New Zealand, and the United States to help with that. So for instance, the U.S. vessel, Coast Guard vessel that traverses through the Phoenix Islands comes from Hawaii, heading towards the U.S. Line Islands. And when it goes through this area, they actually put a Kiribati military police on board. And they were actually successful at locating an illegal fishing boat in there a few years ago and impounded that vessel and actually fined the country $5 million, which they actually realized, which was huge, a huge sort of incentive, or disincentive, I should say, for illegal fishing, right? But I think the other thing that we're exploring a lot is this idea of technological advances. How can we utilize essentially underwater drones and autonomous vehicles to try to track vessels and where they move? And so that's part of, in fact, the dialogue that goes on for countries when they're negotiating fishing treaties. So some of the work going on now, at least with Kiribati, is negotiating with the EU and the US and their fishing treaty to make sure that the fishing fleets are respecting the boundaries of marine protected areas. And that's pretty new development. So, again, as Daniel says, it needs a lot of work, but I think that there's a lot of people thinking about this and how to really make an impact